Let's go to Lico 930 binary subarray with sum. And for this question, it give us a binary subarray and ask how many subarrays have the sum equals go, right? I just record a video which do the prefix sum and map approach. I said this question also can do the sliding window. And I think I'm going to redo this one in sliding window approach because if we will use a prefix and the space complexity will be ON, right? But if we do sliding window approach, we can have a constant, we don't need to, we just need to have a sum variable, and we don't need to have the map to store whether we see this prefix or not, right? So what we do is that we know how many, we are counting how many subarrays equals to sum. That is, we actually this one will convert to count number of subarrays small equal than go, right? And the minus count number of subarrays smaller equal to go minus 1. So if we convert, calculate count of the subarrays smaller equal to go minus count of number of subarrays smaller equal to go minus 1, that will be our result. Count of numbers subarray equals go, right? So we write a function called count. So that will be nums, and let's put a target. Okay. So what we need is that we return count nums go minus count nums go minus 1, right? So for this one, we'll have int result equal to 0, and then we have prefix sum variable equals 0. J variable will be our left point equal to 0, right? So what we do is that int I equals 0, I smaller than nums of the length I plus plus, right? So we'll have sum every time we move I, will have sum plus equal to nums I, right? So I say while j small equal to I and sum greater, right? We want to count a smaller, less or equal, right? So when sum is greater than our target, that means the window size is too big, right? So we'll have j plus plus, and while this j plus will have sum minus equal to minus j, right? So when we jumping out of this while loop, then that means from I to j, right? Every subarray will meet the condition, right? So we fix the I as a right bound, and our j can move from j to I, right? So our result will plus equal to I minus j plus 1, and then in the end, we return result. Right? So doing like this way, the time complexity will still be ON, right? But the space complexity will be constant. You see, this is faster than the use map approach. Maybe the map, because the time it use some complicated data structure, right? Convert this one to Python. Let's write this one in Python as well, right? So so we need to define the function count, right? Define count. So we have this nums already passed, right? So we just need to have target, right? because it's inner function, right? So these nums, we don't need to pass as parameters. So we just need to have um, target. For example, this is the int, right? And this one return int. Okay. So what we do is that we have result equals to 0 and j parameter is equal to 0, right? And we have pre-sum equals to 0, 0, 0. Okay. So what we do is that for I in range length nonce, nonce. And we'll say we'll have p sum plus equal to nonce I. Right? So we'll also have while j j smaller equal to I and p sum greater than target I. Then we'll have p sum minus equal to nums j, and we'll have j, we should move one plus equal to one, right? And if we jump this while loop, that will have result plus equal to I minus j plus one, right? And then return result. And for our main function, we have to return count, count, go minus count, go minus one. Okay.